Hello and welcome to my science tutorials. In today's video, we want to look at ratio and proportion, where we'll be looking at how to determine whether a pair of ratio is proportional or not. Now, this video is very useful for children in grade 5 all the way to grade 9. And if you are in any of our African continent and any of the English-speaking countries, those of us in lower primary to junior primary will find this video helpful. So from class 5 all the way to JHS 3, you'll find this video helpful. Now let's dive in to see what this is all about. So let's have a look at the first example. Say we have 1 over 3 and 8 over 24. Okay, we are to determine whether this ratio are proportional or not. So if it is proportional, we write yes. If it is not proportional, we write no. Now in this case, this is very easy. We just have to simplify the biggest fraction that we have, and then we find our answer. So if you look at this 1 over 3, this is the simplest fraction that we have, so we can break it any further. But 8 over 24 can be broken down. So what I would do is to break down 8 over 24 and see if it will give me 1 over 3. If it gives me 1 over 3, then yes, they are proportional. If it doesn't give me 1 over 3, then they are not proportional. So this is where we are going to write our answer, whether yes or no. We're going to write it in this box. But let me solve the problem over here. So so let's break down 8 over 24. So what I will do first is ask myself, which number can go into 8 and at the same time go into 24? That is what I ask myself. Now there are a couple of numbers that can do that. 2 can go into 8 exactly without any remainder, and at the same time go into 24 exactly without a remainder. That is 1. 4 can also go into 8 without a remainder, and 4 can also go into 24 exactly without a remainder. Another one, 8 can also go into itself once and can also go into 24 3 times. That is also an example. But let me so we have 2, okay, 4 and 8. These are the numbers that can divide each of these numbers exactly without a remainder. But let me go with 2 for this example. So 2 will go into 8 4 times. Okay, so 2 will go into 8 4 times. Then 2 will go into 24 12 times. Okay, now the same 2 again can go into 4 2 times. Then that 2 can go into 6 or can divide, that 2 can go into 12 or can divide 12 6 times. So we have this. And then we can break it further because 2 can still go into 2 and 6. So 2 will go into itself once and will go into 6 3 times. So we have 1 over 3 here when we simplify 8 over 24, and that is exactly what we have at the beginning over here. All right, so let me clean this, and then we look at the other factors as well. So we said 2, 4, and 8 could give us our answer. So let's look at that. So if I decide to use, you only need to use one, but just for explanation's sake, I'll go through all of them. So if I decide to use 4, 4 will go into 8 2 times, and then 4 will go into 24 6 times. Okay, that is if I'm using 4. Now after that, I have 2 over 6. Now mind you, 2 over 6 can still be broken down further. Okay, so 2 will do that. So 2 will go into itself once, 2 will go into 6 3 times. So even if I still break it down using 4 in the beginning, I still get 1 over 3. Now let's look at 8 as the final one. So 8 over 24. So if I use 8, 8 can divide itself once, and then 8 can go into 24 3 times. And so regardless of any factor that I use, I'm still going to get 1 over 3 as my final answer if I break 8 over 24 down. So if I look at this, if I break 8 over 24 down, I'm going to get 1 over 3. So this is equal to 1 over 3. And so doing 1 over 3 is equal to 1 over 3. And so therefore this is proportional. So I'll write yes here. it is proportional. So that becomes my answer. All right, then let's have a look at another example. Okay, so example number 2. I am to determine whether 4/5 and 9/10 is proportional. So I'll write my answer over here, whether it is yes or no. So like I always say, we have to break down the ratio that we have to see if they will all be the same after we break it down. So if you look at this, we realize that 4/5, there is no common factor or no common number that can go into 4 exactly without a remainder and at the same time go into 5. Okay, except 1. 1 can go into both, but 2 will go into 4 exactly, but it will not go into 5 exactly. So we can use that. 3 will not be possible, 4 will also not be possible. So this ratio, we cannot break it down. Now if I come to 9/10, apart from 1, no other number can break down these two numbers exactly without a remainder. That is, if I decide to use 2, 2 can go into the 10 at the bottom over here, but cannot go into 9 exactly without a remainder. If I decide to use 3, okay, 3 can divide 9 3 times, but 3 will not be able to go into 10 exactly without a remainder. So if I look at these two examples, there is no way I can break any of them into any simpler term any further. So therefore, they are not the same. So my answer over here is a big no. Capital O, capital N, small o. All right, so that is that for the second one. So let's have a look at another problem. So number 3, I have 18/41 and 3/7. I am to determine whether they are proportional or not. As always, my answer is either yes or no. Now if I look at this, I have 3 and 7. Okay, so 3 and 7, that this is the simplest form that it can go. No number can further simplify them, so we will leave that. But let's take the first ratio, which is 18/41, and let's think of any number that can simplify them or divide them. The number has to go into them exactly without a remainder. Now if you look at the denominator over here, it is 41. It is an odd number, so 2 cannot go into it exactly without a remainder, and so therefore no other even number can go into it exactly without a remainder. But let's look at 3. So if we divide 41 by 3, we are going to get 13.6, so we can use 3. If we decide to use 4, we'll get 10.25, so we cannot use that as well, and any other number cannot go into it any further. Okay, since 2 cannot go, 4 cannot go, we can conclude that no number, or there's no common number that can go into 18 exactly without a remainder, and the same number can go into 41 exactly without a remainder. So we cannot simplify 18/41 any further, and since we can do that, it means that these guys are not proportional, and so therefore my answer is capital N, small o, no. All right, so let's look at the fourth example. So for the fourth example, we have 3/2 and 27/18. Okay, as always, my answer is either yes or no. All right, so let's have a look at the solution to this problem. Now if I look at this, 3/2, this is the simplest fraction I have over here. I cannot break it down any further, so I will leave that alone. But if I look at 27/18, maybe I might be able to break it down. So let's look at something. Apart from 1, which other number can divide 27 exactly and 18 exactly at the same time? So apart from 1, let's look at 2. Because 27 is an odd number, 2 cannot divide it. So 2 is out of So 1 is out of the equation, 2 is also out because 2 cannot divide 27 exactly. But let's look at 3. Now if you look at 3, 27 divided by 3 is possible. We'll get 9. And then 18 divided by 3 is also possible. We'll get 6. So we will use 3. So since 3 can divide both, we will use 3. So it means that the first one, I have 27 divided by 3, or 3 will go into 27 9 times, and then the same 3 will go into 18 6 times. So I have 9 over 6. Now I ask myself, which other number can go into 9 and 6 at the same time exactly without any remainder? Now if I look at it, 3 can do the exact same job for us again. 3 can go into 9 3 times, and then 3 can go into 6 2 times, or 3 can divide 9 3 times, and then 3 can divide 6 2 times. Okay, so if we simplify 27 on 18, we are going to get 3 over 2, which is the same as the beginning ratio that we have over here. So it means that 27 on 18 2 is also 3 over 2, okay, as a ratio. So therefore 3 over 2 and 27 on 18 are proportional. So my answer over here is yes, they are proportional. So now that we've gone through 4 examples and we've seen how to answer this problem to find whether a pair of ratio is proportional or not, let's go ahead and have some homeworks so that we can try our hands on them and comment the answers in the comment section. So I'm expecting for you to write number 1, number 2. I'm going to give 4 homeworks. I'm expecting just write number 1, whether it's yes or no, just yes. Number 2, no. Number 3, no. Number 4, yes, something like that. And that will be all. So let's take our homework. Okay, so example number 1, I have 4 on 2 and 19 on 9. So please, if it is yes, write yes. If it is no, write no. Number 2, 5 on 6 and 15 on 18. Okay, if it is yes, write yes. If it is no, write no. Number 3, 8 on 6 and 4 on 3. If it is yes, write yes. If it is no, write no. Okay, and then number 4, 24 on 32 and 27 on 36. Okay, so you can break it down. If it's yes, it's yes. If it's no, it's no. Now if you look at the 4th example, okay, example number 4, you realize that all the ratios are big, so we have to break all of them down to see if we will have a common ratio and compare if they are the same before we decide our answer. So it's not always the case that one of them will be a simple ratio and then you have to break down the other one. We can have instances where both of them are bigger ratios and you need to simplify all of them down before you compare to see if they are proportional or not. And then number 4 is a typical example. So the question is, determine whether or not each pair of the ratio is proportional. Determine whether or not if each pair of ratio is proportional. So you have 1, 2, 3, and 4. I expect you to just write the answers in the comment section as 1, yes or no, 2, yes or no, 3, yes or no, 4, yes or no. And that will be your homework for today. So thank you so much for watching. I'm looking forward to your answers in the comment section, and I'll see you in the next video. Bye bye.